here on question 3 on page 174, where it says find equivalent fractions so the fractions in each pair have the same denominator. Here we have 8 over 3 and 6 over 4. One of the easy ways to do this is by prime factoring the denominators. So if we prime factor 3, 8 over 3, 3 is a prime number. Prime factor 4, that's 2 times 2, so we have 6 over 2 times 2. What we need to do is make sure we have all the same prime factors in both fractions. So here we would need a 2 times 2, and what we do to the bottom, we're also going to multiply to the top to get equivalent fractions. And here we have a 2 and a 2, we need a 3, so we're going to multiply by 3, and then we're going to multiply by 3 up there. So what we end up with is 8 times 2 is 16 times 2 is 32, over 3 times 2 is 6 times 2 is 12, and over here we have 6 times 3 is 18, over 2 times 2 is 4 times 3 is 12. So here we have two fractions with equivalent denominators, or common denominators. And we see 32 over 12 is bigger than 18 over 12. Another question here, if we're looking at D, it's a little bit different. So we have 11 over 10, and we have 20 over 15. The same idea goes though. We're going to prime factor the denominators. So we have 11 over 10 is the same as 2 times 5. 15 is the same as 3 times 5. And so what we notice here is that 5 is the same on both. So we don't need to multiply by 5. But this one here we have 2, 5, we need a 3. So we multiply by 3 over 3. And this one we have a 3 and a 5, we need a 2. And so we end up with 11 times 3 is 33, over 2 times 5 is 10 times 3 is 30, and 20 times 2 is 40, over 3 times 5 is 15 times 2 is 30. So that's how you get a simple way to get prime factors, using prime factors to get a common denominator.